Hello everyone. So in this video, as the follow-up of the previous video, I will try to cover the modular programming stuff. First of all, what do we mean by modular programming? The reason behind the fact that we tend to use modular programming is that usually we try to like hide the implementation. I mean, separate the implementation and abstraction stuff from each other. And this is a very good practice if you are doing large projects, for instance, working on large projects, or how to say to develop some projects in teams. So this might be helpful for those, and also hiding the abstraction will make it safe to work with the team. Okay, so here now I will try to implement the ideas that I share with you on the same code that I started to write last time. But of course, you can do whatever you want in whichever way you want to do those. Okay, so as I said, the idea is to simply separate the implementation and abstraction. What I mean by abstraction is that we separate the prototypes of functions. For the simplicity, let's start with functions. So when we separate the prototypes of the functions from their definitions, we might achieve the modular programming. And simply put, we will have different types of files in this case. So actually, where should I put? Let me put it here somewhere. So in C, you might encounter .c files, .o files, and and execute. Let me see. Yeah, that's it. Okay. .h files. All right. So usually we use .c files to put our source code in. And what do we use? .o file. Actually, we don't use o files. These are object codes. When you compile your .c files source code, it will there will be some object codes created automatically. And what we use .h files is it's a header file. Okay, so in our case, what do we have here? We have two functions which are like logically, if we take it, like if we try to separate our code in logical parts, here we have, right now we have only two functions, and both of them are about our mathematical calculations, right? So what I do, I take a new file, let's say my math.h, okay, and hit enter, right? So what is my math.h? My math.h will have all the prototypes that I have, that I need to have for that math library. And in my case, I have only two. So I will take a copy of those and put them here. All right. So once I have this, what I can do, instead of listing all my prototypes or function declarations here, and also similarly in any other file that I want to use them, I can basically include the header file. All right, but including the header file can be a little bit tricky. Why? Because if you have a .h file, which locates under the default include folder. It can be different in Windows or in Linux, depending on your system. You can have a look. You can try to search about it in the internet. But if it is in the default include folder, you can use these brackets, right? But if it is in the current folder, right now, you see we are in my math functions.c, right? And I'm trying to use or include my math.h, which is in the same directory. So in those cases, I will basically put double quotes to include my header files. Now, if I compile, let's try to see if it works or not. As you can see, I only changed the header files. I deleted the header files from main file. I put them all in my .h file. Okay, so let me try to compile it again. And as you can see, everything went fine. No errors, no warnings, no implicit declaration stuff. So let me try to run. That's it. This is the same result. So that means in main.c function, my factorial function, or for instance, what was the other function that we created? It was my power, right? My power 3 to the power of 5, let's say. If we compile and run, okay, so the all the functions that you created, or not created, let me say, listed in my math.h file, you can easily use them here if you have the my math.h header file included in your file. Let's see about the definitions. So here we have the definitions. But can you imagine what would we do if we have some other file here, .c file, which needs to use my power? All right. What would happen in that case? I might have to define those functions there and then use them, because otherwise that file will not recognize the definitions. That means the compilation process might be successful, but in the linking process, which comes after the compilation process, this might fail because there is no implementation for instance, my factorial function. In order to get rid of those kind of problems, and in order to be able to just define all the functions once, what I will do, I will create a new my math.c file. All right. This my math.c file will list all the definitions, or so to speak, the implementation of those functions that I want to have in my math.h, right? So basically, as you would guess, I will cut this from here and I will put those here. But now there is another, not wrong, but kind of missing stuff right here, which is if I want to use this my math.h library files declarations or prototypes, I will do include statement here as well, this time adding or including the function prototypes that I listed in my math.h. Now it's ready to be used. But let's see what I have here. In my math functions, which is a main function, I can, by the way, rename it to the main.c to make it simple. So in main.c, I have included the function header, the header that I have my functions for mathematical calculations, and I included it. Included it means that I have all those functions, at least the prototypes, here in this scope in my file, which is main.c. Now let me try to compile first. I am compiling, as you can see, GCC. No, you cannot see in this case. Okay. GCC, my math functions. No, it's not my math functions. It's main.c. All right. So I'm trying to compile this file and hit enter. When I compile, what happens? It says that undefined reference to my power. Now, what does this mean? It doesn't say that I don't recognize my power, but it's undefined reference. The undefined reference. Okay. Let me try to. You see, I just commented line 2 out just to see if what happens if I do not include the header file. Let me see. You see here it's implicit declaration. So that means compiler doesn't recognize what my power is, right? Or what my factorial is. But if I uncomment it back and compile, you see the error, or not error, let's say warning is kind of different. Actually, it's not a warning that is done by compiler, but it is a warning that is sent to us by the linker. And what does this mean? This means, okay, I know what is the prototype, or I know that you have this kind of function, but I don't know what it does. Okay, I don't know the implementation. I don't know how did you define your function, for instance, in our case, my power or my factorial. So in order to let compiler know, okay, in order to provide this, we need to list all the .c files that we need. So in our case here, what do I have? I have my math.c as well. So I will say my math.c. Okay. Now here, what happens when I say gcc main.c mymath.c, and let's say I want to have executable file executable. I'm just trying to change the name so that you will see that it's not main or it's not a.out, it's something different this time. So what happens in this case? GCC will try to compile main.c and mymath.c separately. And as you saw before, we have .o file. It will create .o files for both of them, the object files. And then when the linker, as the next process, when the linker comes in, it will try to merge or link those object files to one another. In our case, we have only two, but this can be more than two as well. And then eventually it will create an executable file. In our case, it is, let's say, executable file. Let me hit enter and see, you see, everything went fine and I have executable file. All right, successfully created for me by the linker. Now let me try to execute. As you remember, we have to execute it by using // and the name of the executable file. When I hit enter, voila, that's it. This is the thing that we wanted to achieve. A quick recap. Now, what we did, we just list all the prototypes of the functions in our .h file, and we implement them usually in this, like in order not to confuse, we usually put the file names the same, but it's really not necessary. You can choose whatever name you prefer, and then we implement them. We define each and every function that we are going to use. Right now we have only function declarations here, but later on in the future you will see that you can also put structure a new, like creating a new data type, a composite data type, for instance, structure, or you can create your unions here in .h files. Usually we do them in .h file. In .c file, we usually tend to use them instead of defining them or declaring them, all right, for the first time. In main.c, we try try not to list .c files in include statements. Include statements usually use .h files. All right, this is like for, I mean, header files. This is for header files. Okay, so that's it, I guess. Again, in order to keep it short enough, I will pause the video here. Hopefully, in the next video, we will try to discuss the differences between extern and static keywords. What are the differences? What are the usages? How do we use them? And so on. So take care, try to grasp all the ideas, try to digest everything, and take a good care of yourself. See you in the next video. Bye bye.